Hello boys and girls, welcome to our last video lesson in chapter 4, our chapter on polynomial functions. Okay, looking at this problem right here, we got problem numero cuatro, number 4. It says write a cubic function whose graph is shown. Okay, looking at the graph right here, it looks like it's a third power function. It's a cubic function, so it's a third power function. And my leading coefficient is positive because it's up on the right and it's down on the left. And you can notice now I have uno, dos, tres, 1, 2, 3, 3 x-intercepts. So I'm going to write this as a function. Let me get my marker here. I got y equals some constant a times x minus 2. That's my first root right here. I got x plus 1. That's my root of negative 1 right here. And then also x minus 3, or x plus 3, for my root of negative 3 right there. Okay? And now I just need to figure out what my a is, and I'm going to do that by inputting this point, negative 2, 4. I'm going to plug in that point into x and y and see what happens. So when I do that now, let me change colors. My y is now 4, because I'm inputting the ordered pair, negative 2, comma 4. I can input any point on my graph that's not one of the x-intercepts, because if I do that, I'm going to get 0, 0. But any which way, so 4 is equal to a times x. X is now negative 2, so negative 2 minus 2, so negative 2 minus 2, that's negative 4. Negative 2 plus 1 is negatory 1, and negative 2 plus 3 is positive 1. So now I have 4 is equal to a times negative 4 times negative 1 times positive 1, which is positive 4. So 4a is equal to 4. Divide both sides by 4. I get a is equal to 1. So now when I have that, I have a couple of choices here. I can leave this as y equals 1 times x minus 2 times x plus 1 times x plus 3. And that is the equation in roots form or in factored form. If it says write a cubic equation in standard form, I'd have to triple FOIL this out. And in fact, anybody who correctly triple FOILs that out and sends me that triple FOIL in an email, I'll give you a bonus point on our next test or quiz. Okay, our next topic here is called finite differences, and we're going to use this when we're looking at a sequence of ordered pairs or terms in a function, and we're going to try to figure out what type of function it is, and I'll show you what that means in a minute. But let's define differences first of all. First differences are the differences of the terms of a sequence. So we just take all the terms of our sequence and subtract them. Our second differences are our differences of the first differences. Our third differences are our differences of the second differences. Our fourth differences would be the differences of the third differences, etc. So as we look right here, if my x's were my n, so I'm going to write right here x, and let this be my y right here. Okay, a sub n. So if we're looking here at n or x, if x were 1, 2, 3, 4, 5, 6, 7, do we recognize our y's now are 1, 8, 27, 64, 125, 216, 343. Our next one is going to be 512. I'm hoping you see a pattern. Do you see a pattern? Very, very good. The pattern is that these are all cubes. So this is 1 cubed. This is 2 cubed. This is 3 cubed. This is 4 cubed. This is 5 cubed, 6 cubed, 7 cubed, 8 cubed is 512, etc. So this function, if we were to write this as a function, this would be y equals x to the third. And we're going to show how we can figure this out. So what I'm going to do is I'm going to take my first differences of my sequence. So looking right here, my first differences of these terms are going to be, what's 8 minus 1? Well, that's 7. What's 27 minus 8? That's 19. 64 minus 27 is 37. 125 minus 64 is 61, etc. 216 minus 125 is 91. 343 minus 216 is 127. These right here are called my first differences. They are not all the same, so let's keep going. My second differences are going to be my differences of my first differences. So 19 minus 7 is 12. 37 minus 19 is 18. 61 minus 37 is 24. 91 minus 61 is 30, etc., etc. These are my second differences. These are all still not the same number. So I'm going to subtract once again. 18 minus 12 is 6. 24 minus 18 is 6. 30 minus 24 is 6. I'm seeing a pattern. 36 minus 30 is 6. These are my third differences. They are all the same, so therefore I now know that this original function is going to be a third power function because my third differences are all the same. If my second differences had all been the same, it would be a second power function. If my first differences were all the same, it would be a linear function. If it took me to get down to the fourth differences, if my fourth differences were all the same, it would be a fourth power function, etc. Okay, so for this problem right here, we're going to find a rule, and we're going to find an algebraic formula, an algebraic function for these terms. In other words, if x were 1, y would be 7. If x were 2, y would be neg 4. If x were 3, y would be neg 13, etc. So if you want to write right above here, we can actually write x is 1, 2, 3, 4, 5, 6, 7, 8, etc. Okay, so you guys right now use your differences to find our first differences and see if they are all the same number. If they're all the same number, then you will know that we have a first power function. Go ahead and subtract to get our first differences. Okay, you should have found our first differences are right here. Negative 4 minus 7 is negative 11. Negative 13 minus negative 4 is negative 9. Negative 13 minus is plus. So that's negative 13 plus 4, neg 9. Neg 14 minus 13 is neg 1. Negative 1 minus 14 is 13. 32 minus 1 is 33, etc. Here are our first differences. These are not all the same number, so now we need to find our second differences. Go ahead. I'm going to stop the tape. I'm going to go grab a cup of coffee, and you guys find the second differences. Okay, you should have found your second differences. Negative 9 minus negative 11 is positive 2. Negative 1 minus negative 9 is positive 8. 13 minus negative 1 is 14. 33 minus 13 is 20. These differences is 26, and the difference of these is 32. These are our second differences. These are all not the same, so let's find our third differences, and hoping very quickly you can see the third differences are all going to be 6. 8 minus 2 is 6. 14 minus 8 is 6. 20 minus 14, 6, 6, 6. These third differences are all the same, so now we know that this function is going to be a third power function. So this page is way back in your notes, I think from either chapter 2 or one of our previous sections on how to do scatter plots and linear regressions. Okay, but we can do cubic regressions. We're going to do a cubic regression right now because this was a third power function. Okay, so to do a cubic regression on the calculator, we're going to enter our data into the stats, and then we're going to do a regression, and I believe it's probably going to be number 6, which is going to be your cubic regression. Okay, don't forget to store your regression in Y1 by going to vars, Y-bars, function, and then to Y1. And please make sure your diagnostics are on. Turn your diagnostics on, and we've done all this before. Okay, you can see on my calculator now, I've entered my list. You can't see 8, but if I scroll down, you would see 8 too. 8, I think, was 182, so 8, 182. My x's are 1, 2, 3, 4, 5, 6, 7, 8, and my y's were 7, neg 4, neg 13, neg 14, neg 1, 32, 91, and 182, right? So then, I'm going to go to the next slide now. I do a regression. Okay, don't forget to store your regression in Y1. I guess you can store it wherever you want, but Y1 is fine. And then go to calculate, hit enter, and there is our answer. A is 1, B is neg 5, C is neg 3, D is 14. I don't have my R squared here, but your R squared should be perfect. It is 1. This is a perfect regression. And so our final answer is going to be in the form ax to the third plus bx squared plus cx plus d. So a was 1, so that's 1x to the third minus 5x squared minus 3x plus 14, and there is our cubic function. If you write y equals, then it becomes our function. Hey, that's it, folks. Have a great day, and we shall talk to you soon.